Hi everyone, in this video we will be going over estimating irrational roots. Our essential question for today is, how are irrational roots estimated and how are irrational roots ordered when compared to rational numbers? So there's kind of like two questions today because there's a lot of information in this, but it's actually a quick set of notes. But again, how are irrational roots estimated and how are irrational roots ordered when compared to rational numbers? So first, let's go way back and think about rational and irrational numbers again and the difference between these two sets of numbers. So think back all the way to Unit 1, and this was actually the very first lesson that we had. And the real number system consists of two types of numbers, rational numbers and irrational numbers. So let's think back. Rational numbers are real numbers that can be written as a simple fraction. So for instance, if you remember the song that we learned, rational numbers are integers plus fractions. And some examples of these could be really any number that is a positive or a negative number, a fraction, basically numbers that don't have never-ending decimals, okay? And so any of those numbers would be rational numbers. Now, irrational numbers, on the other hand, are numbers that cannot be written as a fraction. So this means non-repeating decimals. So those decimals that go on forever and ever, but do not end. So some examples of these would be pi, the square root of 2, and some imaginary numbers as well. And we're going to talk a lot about this type of number right here today, so irrational roots. Okay? All right, so let's talk about rational roots and irrational roots first. Now, rational roots are square roots that, when simplified, do create a rational number. And this will look very familiar based upon our last notes. So for instance, the square root of 16 we know is 4. That is a rational root because it simplifies to be a rational number. 4 is rational. The same idea with the square root of 100 is 10. Or you could even do this with a fraction and say the square root of 4 over 9 is 2 over 3. All of those create rational numbers because they can all create a fraction. Now, there are things that are not rational, and here are some examples of irrational roots. Now, these are square roots that, when simplified, do not result in a rational number. So for instance, if I try to find the square root of 12, I get this really long number of decimals. They don't repeat and they never end. Now the square root of 105 does the same thing. It has decimals, they don't repeat, and they never end. So when you're looking at these, you can see that these are irrational because they go on forever and they do not end. All right, so you've got a couple practice problems here. Make sure you read the directions carefully. This first one is asking for you to choose the answer that is not a rational number, and this one is asking you to choose the one that is a rational number. Take a second, answer this, and you can put this in Edpuzzle. One quick note, you do not have to write this on the left side of your notes because we're going to put something else there in a second. All right, now let's talk about comparing and ordering irrational roots. So how are irrational roots ordered when compared to rational numbers? Now you have this chart that you're going to put on the left side of your interactive notebook. Okay, you can put it in however you would like. This is a square root table, and it's kind of a quick cheat sheet for you to find some of the perfect squares quickly. Now, this foldable represents the first 25 square roots. Obviously, there's much more than this, but this does give you a good start on the first 25. It's going to be very, very helpful when you are comparing irrational roots in a second. So let's look at an example. So example number 1 says, between what two numbers is the square root of 70? So when you're looking at this, you want to come over to this chart and find out, well, where would the square root of 70 be? So if I go down here, square root of 1, 4, 25, 76, 49, 64, and 81. So we know the square root of 70 would be right between here, right? Because it's between the square root of 64 and the square root of 81. So that means that the two numbers that the square root of 70 would be between would be 8 and 9. Pretty easy, right? Let's try one more. This one says between what two numbers is the square root of 395, so that's much bigger. So now let's look at the larger square roots over here and find out where 395 would fall between. And it would fall between these numbers right here. Okay, so right here. Because you can see that the square root of 395 would be between 361 and 400. So the two numbers that we have that it would fall between would be 19 and 20. So that's the first part of comparing them. As you can see, it's pretty easy. Now you have another foldable, and it looks like this, but I'm only going to show you the first 3 lines. You guys will have to work with the rest. But this is going to be really helpful in helping you to compare irrational roots when you're not using a calculator, because you might not be allowed to use a calculator on our upcoming quiz, because I want to see if you can understand where these irrational roots fall on the number line. Now, the first part of filling out this table is that this top part is going to be your decimals, okay? The bottom part eventually will be the roots, but first, take a few minutes and fill in your decimals just like you see I have done here. So all I did was I said, okay, this is 1, so this is 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, all the way to 2. And then between 2 and 3, we've also got our decimals, and 3 to 4. So take a minute and fill this out all the way to the end of the foldable, because I didn't show you everything that's on the foldable because it's just really long. So take a few minutes and do that. Okay, so now that that is filled in, we're going to start filling in the square roots. And this is actually very simple. So the square root of 1 is simply 1, or the square root of, the square root of 1 is 1. So we would have the square root of 1 underneath the 1 because those two things are the same. Now the next one, as we go up, we just go in numerical order. So that's now the square root of 2. And then from there, we've got this next line over here, and that becomes the square root of 3. And then look what happens. This makes perfect sense, right? 2 is the same as the square root of 4. So see how that goes in perfect order. Now, when we go down here, we can do the same thing. Okay, the square root of 2 again, the 2 is the square root of 4. And then we just fill in the numbers up. So square root of 5, 6, 7, 8, and 9. This is where we know that we've done it right because the square root of 9 is 3. So that's perfect. And then we do the same thing on the next one. So as you can see, it's really simple. You're just filling in these numbers. And when you get to the ends, you see the perfect square roots. So again, the square root of 16 is 4. So we know we've done this right. Now I want you to take a few minutes right now and fill in the rest of this table with those square roots. Okay, now let's look at some examples. So if we were given the square root of 12 and asked to compare it to 3.4, but you didn't have a calculator, you'd have to figure out, well, am I going to use the less than, the greater than, or the equal to sign? So let's find square root of 12. It's right here. And then I see 3.4 is right there. See how easy that is to compare these numbers now that you have filled in this chart? Instead of having to go through it by hand or try to use a calculator, this actually makes it much simpler because we can see automatically that 3.4 is less than the square root of 12, or in the same way that the square root of 12 is greater than 3.4, so our answer just looks like this. Okay, let's look at one more example. So now we've got the square root of 5, and how can we compare that to 2.4? So again, I find the square root of 5, and here's 2.4. Now when I look at this, I can see that the square root of 5, it's less than 2.4. So I just use the less than sign. That's pretty simple. All right, here are a couple problems for you to try. Do not use a calculator to compare these numbers. Use the table that you created and then put in the signs that match that. Take a few minutes and put those answers into Edpuzzle. All right, and you have 2 more practice problems that you're going to try. In this case, you're going to use a calculator and find the exact values of the square root of 70 and round it to the number that you see on Edpuzzle. So that is all for our notes today. If you have any questions, let me know.